Attention, please, everybody. Attention, please. No noise, everybody. No noise.
Bluetooth mode.
Please settle down, everybody.
Connected.
Good evening, everybody. This is CNC 322 class. No noise, please. Hey, this class is another class, please. Let's behave so. Please, if I send you out, let me not come back. You overheard me talking sick, calming you down, yet you refuse to be calm. Abba, this is no more secondary school. Right? So, we're going to be talking about digital communications. This is the first class. Last Saturday, I was there, but there was a mistake in the timetable. Yeah. So, the timetable planner puts all the 3 courses I have, CSC 334, CSC 222, CSC 334, all on Saturday 4 to 6. So there was no way I could teach 3 courses simultaneously, 4 to 6 at the same time. So I thought CSC 334, this is a bigger class, that's very good. So that's exactly what I wanted to first address. Meanwhile, my name is Dr. Oguntunke. So this is my WhatsApp number. You can call me anytime. You call if you can't get that true voice, you can chat me, I will reply you anytime. So please, the essence is for us to do well in this program. See, over time, it's been noticed that PLC people do not read. In fact, that's what gave back to these physical classes. So please make the best use of it, and let's get a better time together. So about digital communications. So we'll be working together in this. I want us all to really participate. So the first thing we're going to be talking about is data. And it's all about data compression and coding. So when we talk about data compression, let me just give this.
Disconnected.
Let me give this very common analogy. Let's say I have a box and I'm traveling, and I have to go with some fairly much load. The ability of me traveling with such loads, maybe shoes, dresses, some gadgets, probably my laptop, and all sorts of things, depends on how I can manage my space in that bag. probably squeeze some, put them, in here and there, fold some, push them in, and somebody else can at the same time add the same bag and have very few things and say, man, it's filled. It depends on how I can manage my space. So it's a kind of organizational issue. To have that bag contain all I needed to take to travel. And so that can be why somebody will say, in a route go, we know nobody, whereas somebody else can, at the same time, use the same bag to do things by matter of organization. So, we want to talk about data compression. That's exactly what I'm about to talk about in this data compression. Data compression has to do with reducing redundancy so that we can reduce the size of the data and use less network bandwidth to send our data for the same size of data. I have data to send, but I want to remove the unnecessary things, unnecessary details, so that I can send something that is less in size and use less network bandwidth to send that same quantity of data. That's something about data compression. It's a concept of reducing redundancy in stored or communicated data, thereby increasing effective data density. The data compression method has existed for almost 40 years from the work of scientists such as Shannon, Fano, and Hillman in the late 40s to a technique developed in 1986. So, and this data compression can be applied to file storage. I don't know whether you have probably sent some files, maybe audio or video, on WhatsApp platform. WhatsApp platform will tell you it's more than 16 meg, sorry. So you cannot send it. Are you following me? And you want to reduce this file. This same file we play out normally as audio whenever you want to play it. Yet, if you use some data compression, application, you can reduce it to 12 meg, 8 meg, depending on the effectiveness of such you'll be able to send it. Once it's sent, WhatsApp will send. Except you go and pick it as a file. That's when you can send something more than 16 meg on WhatsApp. So this is what we are talking about. Even though you have now reduced it to less than 16 meg, it will still play out. You will hear the voice. If it is video, you will still see. But the point is that some things are not really necessary. Okay? If I'm to maybe play a video file, even though the resolution might not be too solid, I follow you, yet I can still see what they are talking about. So also the audio too. After having compressed it, there will be some little loss in quality. I follow you, because there are different types of method for compressing files. We have lossy compression, we have lossless compression. So are you following me? There are some we do so that you can lose some quality, in the file you are sending. Some you will not lose quality. But in data compression generally, what we are aiming at, one, we are able to reduce less storage. Two, we want to reduce, unnecessary details so that you can do what? You can, have lesser, size, as well as use less network bandwidth to send whatever file you want to send. Because bandwidth is an issue. If you send a very big file, just see that sometimes your data, source will just be really like this and nothing will go eventually. So, essence of data compression is to reduce size of that file so that you can use less network, bandwidth. Two, to use less storage. Right. So, an application area is file storage and distributed system. That is when you are talking of network. So, it might be viewed as a branch of information theory in which the primary objective is to minimize the amount of data to be transmitted. We have said that information theory is defined as the study of efficient coding and its concern. So, in the form of speed of transmission and probability of error, the categorization of data compression is involved in transforming a string of character in some representation into a new string bit which contains the same information but whose length are small. It's something about reduction in size from one format to the other. Yet the size becomes smaller. The first chapter we will use to document. The second chapter, I found out that the presentation is not too, clear to many people. So I found alternative chapter 2. So, but we use this first chapter the way it is. So you can see that all we have been talking about is about size in form of storage, size when you need to transmit or transform from one point A to another B, and that one will allow you to use less bandwidth to send your data. Right. So the advantages of compressing data are to store or transmit reduced size of data. The essence of data compression is to get a reduced size of data to store or to transmit from one point to the other. It's because that is the essence of compressing file on the network. If you are sending file from one point, let's say from Nigeria now, to somebody in the US, somebody in South Africa, that's over the internet, and the internet is the network of networks, or what we call the cloud now. Another name for internet is cloud. So essence of the data compression is for you to use the size of the file and use less bandwidth. So when you compress data, it affords you to send more of such data at the same cost. For example, if I'm to send a 40 meg, let's say a 40 meg data, and I now compress it to 20 meg, the implication is that I can send more of that data, with the same, like that. If I can send 40 meg through my network, but I can successfully reduce it to 20 meg. It means I can send double that 20 meg with the same bandwidth. So it allows you to send more, give the network more capacity to send more data. So that's something about data compression. Then we come to coding. Coding is a way of representing your source message into another form that might not be understandable to an authorized and unauthorized user. Let me just give a small explanation about that. There is a branch of computing where we do coding or encoding. That is representing data in an unintelligible manner, way to an unauthorized user. We call that branch cryptography. And there are many schemes, right? Let me just use a particular scheme. Let's use, there are many schemes. We have defense, we have CITEL, we have UIDLC, Cypher, we have one-time pad, Cyber, and so on and so forth. Let's talk about reference. I want to present some things in another form. Let's say I want to say the best way. If I want to code this statement using reference cipher, method, technique, algorithm, the best Yahoo Plus scheme is clear and hard work. I can start. The method says you draw a number of lines. Let's say 3 lines. Please, no noise, no noise. And the next thing you are going to do is to divide these lines into rows and columns. How do we know the number of columns? We have 3 rows already. So we're going to count this 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 40, 41, 42, 43, 45, 46, 47, 48. Which means we will go 48 columns. But it's a very long one. It's a very long one. But let's see if we can try it. Please, no noise. No noise, please. No noise. No noise. So, what do we count? What is the count? 48. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 3, 4, 5, 6, 7, 8, 9, 21, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 1, 2, 3, 4, 5, 6, 7, 8. This is an example of coding or encoding. The rule of reference cipher says you begin to write this sentence diagonally down, up, down, up until you finish everything. So I'll start here. First, Yahoo plus skill is prayer. And hard work. We are trying to enroll or to code that into something else. This is the source code. And whatever we get, we call it either cyber text or code words. Right? So the rule says, no, we are writing from the topmost left, we go diagonally down, up, down, until we finish the sentence. We are going now to be coding in horizontal form. So I can now say T, E, A, P, maybe in fives or fours. Tips, M, P, E, G, G. So I can start A, H, B, S, Y, O, L, S, C. Right? We have E, S, R, Y, R, N, H, R, W, R, E, T, O, U, H, I, A, A. So in reference, cipher or coding technique, we are rewritten this the first Yahoo plus skill is prayer and hard work. So if anybody sees this, you will never know that you are coming from this source message or plain text. You can call this one plain text or source message, or this one code words or cipher text. So these are examples of coding in computing. Generally, or most times, people use this to make messages unintelligible or understandable by people they feel should not have said such a message. This is what we call coding. An example of coding is this. So, and we have different styles. We have different tools for doing their own style. We can also convert that from this, we'll get that exact if you want to convert it. That is not for this class. But I just use this to make you understand what is coding. Coding is a way of representing your message, the source message. The message from you, that's the source message. When it gets to be sent to the receiver, that's code. It's like coded word. Are you following me? So from source message to coded word or code words. So this is the code words. This is the source message. So likewise, that's just giving an example of coding. So, like I just said, a code is a mapping of the source message from the source alphabet into code words. This is the source message or source alphabet. This is the code words. Okay. So this is the basic format. basic form, initial form, before we converted to the code word. Right? So there is a small example we gave there. Let's see, for example, but I think this is better. I mean, you understand this. And mostly secret agents or intelligence agency use this kind of stuff when they are on assignment from one place to the other. They don't want the enemy to know what they are up to, the assignment they are on, what they are saying, so quickly. But the key should have been known to the two parties. If I am agent 1 and she is agent 2, I would have told her we are going to use main fence technique. So anything I said to her, she will use main technique to go back to original message. And if by any means that coded word, coded message gets into a wrong hand, they can never know what it meant. You will have it, but you can't interpret it. So that's something about coding. Yeah, so there's a small example there, but I've given something you can easily. So let's move on. The algorithm that does the coding of source message to the code word is called an encoder, because we are being encoded. So the algorithm that convert this real message to the coded form is called an encoder. And the one that converts back from here back to the original message is called a decoder. Yeah. Now we begin to talk about some terms. We want to talk about a distinct code. A distinct code. That is, if you say something to a code, how do you describe it to be a distinct one? So a distinct code is uniquely decodable if every code word is identifiable when absorbed in a sequence of code words. Okay. For example, we have this as code words. So we can call, say, a code word is distinct if it is uniquely identifiable when you mix it up with other ones. You can see that in this respect, this is different from this. I mean, different from this, and this and that. So we are, mix a number of code words together, but you can see that each of them is distinct or unique, not the same with the other. So we can say this is a distinct code, because they are unique one from the other. Alright? We have found it over again. Excuse me, please. Right. So let's move on. So I want to talk about a uniquely decodable code. And I'll use the one, and you have the material. I want to talk about a uniquely decodable code. For example, everybody look at that material. Look at that table 1.2. Look at table 1.2. Everybody. Do we have the material on you? How many of us have the material? Very many develop the material. Let me quickly draw it on the board because it's very necessary that you can talk about. So, right?
Please no noise, please. No noise. Hello, everybody. Okay, we are talking about a uniquely decodable code.
We are talking about a uniquely decodable code. Now, I want to use this table to explain what we mean by a uniquely decodable code. Right? So, look at this. I want to represent 1. And to do that, I can assemble 2 of these beside one another, Abi, to make it 11, Abi. At the same time, I can pick this, it will still be the same, Abi. I start from here. We have B, 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 okay, 11, B, 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 Abi. Well, at the same time, pick this ready-made 11, Abi. That is D, 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 D. C11 interprets or depicts this. The same 11 depicts that. So which means you can expect 11 in 2 different ways. And it is 2 different values, which makes it not uniquely decodable. Hello? So you can say this code is not uniquely decodable because you can give 2 different, interpretations to 11 in 2 different ways. So this code is not uniquely decodable. Okay. Right? Now, let's talk about the code of discrete information source. A code of discrete information source is said to be non-singular when different source symbols map to different code words. When different symbols map to when different source symbols map to different code words. It's a code of discrete information source is said to be non-singular when different source symbols map to different code words. A code of different source is said to be non-ambiguous if and only if sequence of code words uniquely correspond to a single source message. In this respect, we are talking about a code of discrete information source. I'm laying emphasis on this. Please, it looks boring because it's like it's not something you can easily relate with in the normal natural life. But I want to concentrate. These definitions will definitely come in one way or another in the test or in the exam. Please pay attention and see this material is not something you're going to be reading 2 weeks to exams. Read it regularly, read it every day, and to get it will be when you study. Don't read up as if you are reading, newspaper. Read, yes, understand, and take, your biro, rough sheet or data, and see if you can, apart from that you have understood, you can reproduce these definitions. They really matter a lot. Okay. So, when you say a particular code of discrete information source is not singular, it means different source symbol, like we have here, the source symbol is here, or source code, or source message, map to different code words. We have this. So, in this respect, we have A mapped to 0. We have B mapped to 1. We have D mapped to 11. We have F mapped to that and that and that. So we can say this is a code of a discrete information source, because different source message maps to different words. It do not map to. It's not as if this CCC now become one again. If I now map this one to one again, then it does not satisfy this what a code of discrete information source any longer, because two of source message is mapping to only one of code one. But since it's not like that, each of them has its own interpretation, one to one. That's what we call a code of a discrete information source. Right. So there are different reasons why we put it. One of them is to achieve data compression. We have explained before, data compression has to do with reducing, redundancy, so that you can have reduced data size and save bandwidth and save storage space. So that's one of the reasons why we do compression. We do compression so that we can achieve. So we do coding so that we can achieve compression of data. Another one is ensuring quality of transmission in noisy conditions. We do coding so that we can enjoy or ensure quality of transmission in noisy conditions. This is done by adding extra bits of information to the original, source message that you have, and then process them together. It makes it not sensitive as it travels through one distance A to the until it gets to the receiver. Then it is reversed. Then you have the original message. So that one is about having quality transmission in noisy condition. An example of this is let me just give, it's not in the textbook, but I can use this example. We have in those days before the advent of this web internet source. At the time we used dial-up technology. Who knows that time? Dial-up technology, for you to be able to browse, you need three things. You need your desktop. That time it was desktop. You don't have laptop. So we have the desktop. You need a landline, 910 line. Then you need a modem. So when you want to send a message, you first of all connect using that dial-up. So there should be an SD somewhere, and we used to have two in Ibadan that time. One is Scarlet in Bodija, one is Stenage in Atonireke. So as you now send any information you are sending, data, email, messages, video, audio. Once you send and it's about to go, it will convert to analog signal from digital to analog, so that it can be easy to transmit and make sure that noise does not affect it. So analog will travel from your end to the sender. When it gets there, then it's converted back to digital. We call it, that's why we use modulator, demodulator. So that's why we call something modem. We just M from here and then from here. So we use it at that time to do that. So because even digital signals cannot travel for a long distance, so we convert to analog. So it can travel very long, and it can also be protected along the way. So the third reason is for secrecy. Like I've just showed you, converting from the best Yahoo Plus key is prayer and hardware. I've just secretly, rendered that statement as that lower unintelligible, form or version. So 3 reasons why we do coding. 1, for data compression. 2, to sustain or ensure quality of transmission from one point to the other. The last one is for secrecy, to make a very important message unintelligible to an unauthorized user. Right? Let's move on. So you see a diagram or a small representation of how source messages are encoded in that manual. So when you have a source that gives messages, we call it message generator. A source that gives messages is called message generator. So there are ways of compressing, codes. We have said that the goal of compression is to ensure reduce the use of storage, reduce in size, so that you can have reduce, utilization of bandwidth, network bandwidth, right? So to ensure that, we have a number of schemes or algorithms for doing what? Doing data coding. One of them is Hoffman coding algorithm. Hoffman coding algorithm. Hoffman coding algorithm. So I want to show us an example of how to use Hoffman coding algorithm. Right? No noise, please, no side talk. No noise. Right? We have 6 parts. functions. Yeah. So we have, let me see.
You want to use Hoffman coding. So what we're going to do first to use Hoffman coding is to regroup in order of magnitude of these values, the denominators. 017, 012. So let's rearrange. 0, 0.10, yes. 0.12, 0.16, 0.17, 0.18, 0.27. So I want to return their values to them. Right? 0.10 is what? 2, 6, 5. That's the first step. Regrouping in order of magnitude from the lowest to the highest. We are using Hoffman coding algorithm. Right? So, what we're going to do first, as we have regrouped, we're going to take the first, add them together. Hello? So, 0.10, 0.12 becomes what? 0.22. So, that is, we have 6 before, becomes the seventh one. The seventh one is 0.22. So, this guy, they are gonna be. So, we have 6, 1, 5, 4, and 7. So 6 is 0.16, 0.17, 0.18, 0.27, 0.22. So next, we are going to regroup again. It becomes what? This is the smallest, Abi. This is next. This is next. So this will come here, Abi. So 2, 2, that's 7, 2, 7, what? So we're going to take the next 2 again. Add 0.16, 0.17 becomes what? 0.33. That's the 8th one. So this one we have 5, 7, 4, 8. Then 0.18, 0.22, 0.27, 0.33. Of course, they are in the right order already. So you keep doing that until you finish everything. This is a method that the Hoffman coding algorithm used to represent, a particular source message or number in another way called codes. So we take this again, 0.18 0.22, that's 0, I mean. So that is the ninth value, 0.40. So this one is gone. So the ninth one is 0.40. And so on and so forth. Take this and this again, 0.27, 0.33. So that's what? So the 10th one is 0.60. So this one is gone, Abby, and then we have the last one, Abby. So this one, what will be the answer? 1.00. So the 10th one is going to 1.00. So you can see the way Hoffman and Corrigan have been representing, one of message in another way. You can see that. So that's the way Hoffman and Corrigan coding manipulates or computes to do data representation. All right? So, we're going to move to something else. Move to the information compression error. But in first instance, who can remind us what information compression is? Or data compression? Yes. The volunteer? Yes. The bros with Afro. Yeah, you English. What's data compression or information compression? You can sit down. Just talk aloud for people here. No noise, please. No noise, please. No gisting. Hey, two jolly friends. I don't like them. Yes, Ross. Wow. Yes. Okay. For what purpose? To have reduced size transmission and also what? Faster. Therefore, the size is reduced. You send more message, and also to reduce storage usage. That's the sense of data or information compression. So let's move on. So what we are into now is information compression error. Information compression error has to do with using less memory or less network bandwidth to encode the same information in fewer bits. Two yellow people. Yellow man and yellow lady. Please, no talking in class. So, information compression error can be one of the definitions that you are going to define in the exam. So, all these definitions, please mind them, note them. Please, in the previous exams, people have never been passing. I've lectured more than 2 sets. At least a set has graduated now.
So, please read now. I'm encouraging you. Please read now. There's no point paying this much. Then you come and sit down here. Some are not based in Ghana. Maybe but that person from Lagos, ask question from people. Then you take accommodation not even as cheap as a regular hostel. And at the end of the day, you won't get anything. Some small 000, not 3 or 4 is wonder. So please read these things. This material, please read them. So, let's move on. So, information compression error can determine or detect damage and what and correct. When you send a message, it's possible that any of the bits is damaged. So there will be a kind of corruption. So this information compression error can detect damaged bits and do the correction. So we are talking about having redundancy as one of the reasons why we do coding, so we can have quality transmission. So if you want to encode letters, frequent letters in fewer bits, less frequent bits with more bits are required in order to trade complexity against this. So to transmit from one point to the other, you need to add redundancy. That you can beat the noise, channel noise, source noise, and all kind of interference can be gotten rid of. Yeah. So let's talk about file format now. We have different kind of compression. We have JPEG picture compression. We also have MPEG, movie compression. Let's talk about JPEG picture compression. So the first step is to use lossy compression scheme based on file complexity. So I told you the last time when I was talking about forms of compression. I said loss compression and lossless compression. So here we are going to use lossy compression scheme based on file complexity, and which means, please listen, in lossy compression you might lose some little details. The resolution might not be exactly the way your file, your JPEG file was before. The next thing is to digitize the picture into pixels. Who can help with the definition of a pixel? What's a pixel? Yes, some of us will have been into graphics before. Some of us are engineers who repair, printers and things like that. Yes. Who can? Yes, help us. Please listen. Yeah. Sorry. The number of dots, points, the number of dots per point per location is called a pixel. Thank you. So you digitize your picture into pixels at the same point. Then discard some color information. That's what I'm talking about. You might lose some little point. So discard some color information. Number 4, step 4, adopt less sensitive color variation than brightness. So use less sensitive color. Avoid brightness. Step 5, discard some fine details. There are some spoken about drops of color. Do away with some fine details. So you are losing some little qualities. That's about lossy compression. Originality provides a compressed image as sharp as the original image. Step 7, discuss some fine gradations of color and brightness. Step 8, use Hoffman code. This according that was just learn how to do, run length encoding, and so forth to compress the resulting string of numeric values. Then compression usually ratio 10 to 1 to 20 to 1 for pictures, but for it can vary. Use in web pages, digital cameras. So this kind of compression can be used in web pages. Why do we have to use this kind of method in on web pages? So as to have fast load time. If you go to a site and it's so slow, it's not loading fast, we'll go back there. You don't want to waste your time. You rather go to another correspondent who will give you the same service but fast in loading. And one of the things they do here, I don't know whether you have filled some form. They said your password photo should not be more than 15 KB. What do? You begin to, you refine it. You can first of all crop it. Until you get something you are compressing there. By the time you are cropping, making sure before you get to know it, you have 15 KB. But the point is, you have lost a lot. By the time you load it, you find out you are looking like it. Might not be too sharp the way you started. Is that what? The quality we use. So that's the kind of things we want on our web pages. You do the science of the graphics. It's one of the principles of developing web pages. You do the sense of your graphics as much as possible, so that you can have, even on the entertainment side, you need to make sure that your graphics are not too heavy, so that you ensure fast loading website. So you can use it also in digital cameras. Let's talk about MPEG movie compression. So this one, the first step for doing that, to compress movie in MPEG format, use a lossy compression speed based on human perception. So this one too involves using some level of quality. Second, use JPEG for individual frames. 3, develop a compression of temporal redundancy. So you remove some extra bits that will not permanently affect your movie. But because if you have a movie that is not clear eventually, can you enjoy it? No. But then your movie will play, you see the actors, so you know that then this movie is unfair because the quality is not exactly what is expected. Step 4, segment the image in blocks as required. That's segmentation. 5, transmit the block if there is no change but not the content. 6, transmit the block with the amount of motion. Step 7, predict the motion by encoding the expected differences plus correction. And step 8, separate moving part from static background. So this is how to do video or movie compression. And so we come to the end of that unit for today. So the next unit is talking about the error correction. Error correction. Basic error correction. We talk about the fact that data error can detect damaged bits and can correct it. So we want to talk about error correction. So the essence of detecting error is for correction, so that we can repair what has been damaged. Right? So, we move on. So we have two fundamental notions. The rules noisy transmission. The first one is the channel capacity, that is the ability of that channel medium to send live data and the rate used for transmitting the symbol or the messages. The channel capacity as well as the transmission speed. Those are two fundamental ideas that rules noisy transmission. So there's a diagram there that you need to watch. So when you have a message and you want to send it from one point to the other, the raw message will be coded. And after coding, you do what? You transmit through a channel or a medium. And on the other side, the contrary of encoding or coding is what? Decoding. So the coded, source message here will be decoded on the other end. Then the receiver will have the raw original message. But the truth is this: when you send data from one point to the other, that data, that message, that information might not be completely free from noise. That's not the networking. We talk about interference. Okay? If we have network in this room, any network here, we cannot be free of corruption or interference or errors. Why? We have some sources of interference, like anything that has rotor, like this, or earphone, can cause interference in network cable, and therefore the data flowing through the wires will be affected. It can cause slowness, it can cause corruption, but it can corrupt the data entirely. Anything frozen bomb can also send interference into your network data or magnetic field. If you are running, for example, if you want to connect this building to that other building, especially if you are using normal, ordinary UTP. UTP can do 100 meters, massive. And this place to that place is not up to 100 meters. But we cannot lay the wire on the diagram. We need to bury it. So if you lay it on the diagram, vehicles will power on it, so we kick it, some even knowingly use knife to cut it. So you can use PVC pipe, run the wire to the PVC, and pass it under the ground. By doing that, we are shielding it from interference. It's a form of kind of corruption. So we can shield it from error. Magnetic field, anywhere you have magnetic forces, you can corrupt your data. So you can see that even in this room, you can always have data communication that will be corrupted and that will have errors. So anywhere you are saying, even the one we receive from my own Android phone, and I'm calling this lady in glasses and the face cap, sometimes you hear, I can't hear you very well. It's a kind of corruption. So you can't be free, your message cannot be free. So sometimes you don't even hear the person. Your sender is speaking, your receiver is speaking. But you can't hear him, you cannot hear him. It's a form of corruption. So different kind of things. There was even a time, if you call somebody you know very well, this can even have caused a lot of damage in homes. You call your wife, and a man's voice is speaking it on her. How come my wife gave her phone to boyfriend? So it's happens many times. But recently, I've not been having that. It's a kind of jam. where your signal interfere and go to another destination. So sometimes you wonder, I'm talking to a lady, why is it that a man picked my call? So I found out later that actually, when you call it immediately, my own academic told me the individual you compose it for. And so you know that it's just an error. So you can see from this, if you have the material, you can see the tabulation of message and codes that resulted from such a message when it encounter errors. So any question from anybody? Questions from all we have said? Any question? No? Questions? Yes? What's it? Unshielded to step here. Unshielded to step here. It's a little cable. It's the commonest form of network cable that people use, nowadays. It's cheaper than Oasia, than optic fiber, yet it produces the same fast speed. It's when you strip it, who has tempo? Anybody with what matter? Last word. Okay? You ask the question like this guy. So, UTP cable is like this. It has 8 wires in the. So, at each of them, they are intertwined in pairs. Maybe 8 wires. So this is a rubber jacket to protect it from interference. These wires are also wrapped in very thin, filmy kind of rubbers, very light. So if you want to use this cable, what you're going to do is to untwine it from one another. Then you straighten it, then trim it. We use crimping tool or crimper to trim the wire to size and insert it into RGB connector. Then you crimp. The essence of crimping is to attach each of the wires to corresponding pins on the connector. So that once you insert into the Ethernet port, the wires has connection with the corresponding wires also in the port connected to the motherboard, so that there could be continuity between the wire and the system to carry signals, network signals. That's UTP. Yes?
The compressed image of
You can decompress it. Yeah, you can decompress it. That's from the size back. Some data, there's some data. Have you used zip before? That's the commonest. Are you following me? If you zip the file and use it that form, can't use it that form. If you have like a Word, Excel or something, and there are very many, and you now do what? You zip them to reduce the size. You just see only zip. You won't know what is inside until you have that application zip app, then you unzip it. Then you see that there are many files there. Are you following me? So you unzip. But the type of video and audio, you can use it that way. But the point is, you might notice the degradation in quality. To normal data, textual, numeric data, you can zip it, but you won't be able to use it in that form. You must convert it back to using that same app. Yes. Sorry. Thinking of one me. That's why we know better. Okay. Depend on. That's what I'm saying. That's what I'm saying. If it is, normal documents, you have to zip. That will even be many documents. That's zip file. But if you compress audio, video, you can still use it in that compressed form. You just notice that there's a drop in resolution, voice quality, and like. You can be compressed, compressed audio, video. You can. But the size is going to be. But why be compressing when you can still receive your message, what your video, you have not lost anything. Yes. If you're watching a video and you got that resolution is not complete, does it kill you? Does it affect you? It's not spoil anything. But if you compress some documents, you cannot use it that way. For you to be able to have access to them, you need to compress. Yeah? Look at the one you like, you can open them and stuff like that. Yeah.
We compress and we pass a specific resolution and quality. After sending it, because of how it is made, after sending it through a medium,